right, so our last lesson this week, Design Our Planet. In this lesson, we are going to look at some of the solutions to design a better planet. And not a better planet per se, but a planet that has less of all of these issues that we've just been talking about. Mainly dealing with the consequences of global warming. So in this lesson, we'll actually finish out you'll submit your report in the next lesson, that's due next week, but this is the last of the learning parts. So here we go. What can and should be done to reduce the effects of observed rapid warming? You've observed a warming trend all over the globe that is both recent and rapid. You have seen the impacts of global warming in the present. You then investigated a similar incident in the past and narrowed the culprit to carbon dioxide emitted from human activities. It is clear that humanity can impact our home planet on a global scale. It's now time to see if we can slow, stop, or even reverse some of the global changes we have started. In this lesson, you'll draw on everything you have learned about the Earth to finalize your Blue Planet report. You'll also finish creating your unique plan to preserve our home for generations to come. Out of this lesson, we should be able to define, from observations and data, the roles of various components of the atmosphere as they influence climate. Describe and evaluate the patterns of global climate change revealed through data, including the role of natural and anthropogenic processes. So can you list a few of those natural processes we've looked at? That might be like volcanoes and chemical weathering, photosynthesis and respiration, and anthropogenic being fossil fuel emissions mainly. All right, so based on the images in the right, which of the following areas would be impacted if we reach 2 degrees of Celsius of warming? Select all that apply. Coasts, definitely from sea level rise, ecosystems, biodiversity loss, health, water, food from plants being affected by drought, water drying up, health. We looked at that case of DDT and malaria. That's one example. But with decreased water and food, definitely increases health, or it decreases health to a population. Oh, and here we can learn a little bit more about it. So, okay, water, increased water availability in moist tropics and high latitude, decreased water availability, and increasing drought in mid-latitudes and semi-arid low latitudes. Hundreds of millions of people exposed to increased water stress being not able to get enough water. Food, complex, localized negative impacts on small holders, subsistence farmers and fishers, tendency for cereal productivity to decrease in low latitudes, tendency for some cereal productivity to increase at mid-latitudes. So here you can see how there's like positive and negative effects, you know? There's both with an increased warming temperature, an ability for some crops to work better in different zones. And you notice the trend here from low latitudes to high latitudes. It's harder to grow because the nearby the equator is going to be hotter, and then that's going to move towards these other zones. Okay, health. Increased burden from malnutrition, diarrhea, cardiorespiratory, and infectious diseases. Infectious diseases are able to spread into new zones. Increased morbidity and mortality from heat waves, floods, and droughts. Remember, morbidity is the chance that you're going to get a disease. Mortality is the chance that you're going to die from it. Changed distribution of some disease vectors, a vector being something that transmits a disease. Substantial burden on health services as a result. Coasts, we have more flooding, about 30% of all global wetlands lost. Millions of people could experience coastal flooding each year. And ecosystems, so many effects, specifically looking at loss of species, 30% at risk for extinction. leading to significant extinctions around the globe. So some people say we're in the Anthropocene, and that is the sixth major extinction here that we're experiencing. Increased coral bleaching. A lot of you have really taken hold and looked at that coral bleaching as an event here. Very sad. Most coral bleached, widespread coral mortality. Terrestrial biosphere is out of control, becoming a net source of carbon. Basically, 15% increase, source being putting carbon dioxide into the atmosphere. And they're estimating this at 40% of systems affected. Increasing species range shifts and wildlife risk, we just looked at that. And then ecosystems changes due to weakening of nutrient-bearing ocean currents. And I just go ahead and jot a few of those down if they're anything new to you in your notes. Where to draw the line. In history repeats itself with a twist. You saw some of the consequences from the PETM. This was a global event during which the temperatures increased by 5 to 8 degrees in less than 20,000 years. Today's warming is much faster, but we may be able to slow it down, stop it, or even reverse it to using our resolve, innovation, and ingenuity. Which of the temperatures below do you think is a good target for maximum warming for the next 100 years? For reference, we are at about 0.6 from the 1951 to 1980 average in 2014. Next, you'll test scenarios to reach the target you choose. This will be scored for completing the screen, not for any particular response. Okay, so let's say we want to slow it down to, go ahead and just choose one, but let's say we do, all right, let's keep it at a goal of 1. Let's see if we can use a strategy to get there. Okay, so an emission sector is a group, think of piece of the pie, that produces carbon dioxide. One way to avoid future warming is to reduce the rate at which we release carbon dioxide into the atmosphere, otherwise known as the emission of carbon dioxide. Most of these emissions are a result of our use of fossil fuels for energy. These emissions are often broken down into different sectors, as shown below. Here we're going to select a sector below to explore how reducing its emissions may help meet your target goal. So let's start with transportation. What is the impact of improved vehicle efficiency and reduced use? Gains in fuel efficiency are at the forefront of vehicle technology research. This includes traditional automobile engines, hybrid engines, and even lighter airplanes that have less drag in flight. Coupled with reduced use of combustion-based transportation and new fuels, we can reduce the amount of carbon dioxide emitted by human activity. Using the simulation below, your goal is to explore the impact of varying levels of effort in the areas of vehicle fuel efficiency and reduced vehicle usage. Though higher effort gives us faster results, it will come with higher cost, so bear that in mind during your testing. When you are done, select which actions you want to take. Make sure to include the amount of effort and the year in which you'd like to start, then continue. Only adjust transportation strategies on the screen. All right, so here we go. We can read a little bit more about the data source. It's based on historical anthropogenic CO2 emissions compiled by the Intergovernmental Panel on Climate Change. Future emissions are predicted to increase at historical rates, or 1.25% per year, unless we take measures to reduce emissions. Start dates are the course author's estimates of when new technologies will come online. The model does not include synergy effects from having multiple technologies active at once. Okay, good to know. Let's read the plot. The graph shown is called a wedge plot. Each sector's contribution is represented by the distance between its line and the line below, or the x-axis if it's the lowest line. Adding the wedges gives the carbon dioxide level, which is also where the uppermost line is. Okay, so here's total carbon dioxide, and then this wedge is from transportation, that's from buildings, that's from power and energy, and that's from land use. Okay, so what we need to do here is let's just move around with, so under transportation, if we were to increase the effort, technologies in this sector are going to start later. See what happened there? Because you have to put in more work to get those up and running. my guess. Okay, so here some individuals, governments make modest efforts, emissions drop by 1%. If we make medium efforts, they drop by 3%, and high effort is 5%. So let's notice what happens. Let's go to our baseline. Make a note at the transportation is 129.2. If we get more efficient vehicles, and we try really hard, that goes down to 72.7. So that seems like a good use. Reduced use, so if we all start biking instead, goes down even more. Biofuels, using things like biodiesel, like you can actually use the fuel or the oil that comes off your McDonald's fries, you can put that in biodiesel, or use plants and algae to make those fuels. And then hydrogen fuels, which is a type of car that uses hydrogen gas to produce only water when burned. That's really fun. 35.1. The downfall here is you have to transport a bunch of hydrogen gas, which is hard. That's why we haven't maybe switched to that so much. Okay, so we reduced it quite a bit from 129 to 35 by going high effort in all the technology fields. Okay, let's look at power and energy. Okay, so under power and energy, let's look first at where we're at, 516.7. If we were to increase our effort all the way, with efficient coal plants, 422, natural gas, 281, carbon capture. Power plants continue to burn fossil fuels such as coal and natural gas, but capture and store the resulting CO2 underground. Nuclear, 140.5, which produce no carbon dioxide emissions, replace fossil fuels as the major source of energy. So we're going to talk this Friday, I hope you come, to a person who works with the USGS on uranium cleanup. So uranium's what's used for nuclear energy. And so if you want to find out about like what are all these things have consequences, right? We can't get around that. It's like getting up in the morning. It takes a lot of energy no matter what. So how do we reduce and find the most efficient way to use energy? Wind and solar. And that brings it down even more. That's cool. So as you can add these to your observations, I would start typing in some of these different technologies before you add it and how much effect it's going to have. Okay, I think we have to go to next. Let's investigate buildings. If we went to the highest effort and we made more efficient buildings, that means less heat loss. There's some really cool examples of like earth houses, things made with materials are actually renewable and are not emitting CO2 in order to be made. Ecosystem preservation. So thinking about where we build. If you build a house in the desert, it is going to take a lot of air conditioning potentially to cool it down. So you maybe want to build your house like where there's some trees so you don't have to use as much. Can you think of other ways that you can make buildings more efficient? So in doing that, let's go back to like our baseline. Take a note. Buildings produced 55.4. And we could reduce it all the way to, 15.1. That's a massive reduction. And the last one, land use, how we use our land. Here, okay, so in the mid to late 20th century, forests worldwide were leveled for the needs of civilization, such as housing, agriculture, and business. Recently, however, we have developed plans and techniques to rebuild previously destroyed forest land and farm more sustainably. By doing so, we can not only reduce our emission, but actually remove carbon dioxide from the atmosphere. by reestablishing forests. Yeah, so let's see, someone in their DBA was suggesting everyone has to plant a tree. Like everyone is by law forced to plant a tree. What do you guys think about that? Maybe more radical. Land use. Okay, so here's our land use. We're at 509.9. And if we were to reduce, we would go heavy effort, reduce deforestation, and then conservation farming. Specialized farming and food processing methods are used to reduce the carbon dioxide released during food production, or even build up carbon stored in soil. And that reduced, wow, that was big, 60.2, down from, I think we're at 500, right? 200. Okay, so, all right, so let's go into a little bit more detail. Below is the simulation you've been exploring with every technology enabled. Before you can explore your options, you'll need a baseline for comparison. Set up the simulation below to test what happens when nothing is changed. This means that no new technology is enabled and that no effort is applied. This approach is often called business as usual. What is the level of warming by 2150? Okay, so here's 2150, and we are at, let's go to the temperature graph. Your total temperature here being, we could add up all these wedges. That would give us a really accurate degree. Okay, and so you need to go through and actually set all these to no effort. Okay, and then add them all up. 1.1, 0.5, and I'm writing these down in my notes so I can keep track of these different sectors anyway. And then land use 1.9. Okay, so add those all up. Okay, and I get 7.9. So with no effort, we're over 6 degrees of warming in 100 years. And that is pretty crazy. But where does your plan place the planet in 100 years? Here we've entered your responses from each of the technology tests you perform. You'll have a chance to make adjustments in a bit, but before you do, take a moment to see how the scenario you envision works out. What is the temperature rise by 2150 with your likely scenario? Okay, so go ahead and add up temperature for your own, what you've determined to be where you should have all these toggles. Okay, so based on what I chose, I got a total of 3.6. And let's see how good we are as a society. If we put every maximum effort on every single possible technology, where would our temperature rise to? So go ahead and do that. So for each one of these, go all the way up to maximum effort. And then see what your number is. And I already actually calculated that the first time. That's where we're at. Okay, it's not letting me pass unless I do it all. So go ahead and do it all. Set all these, take all the efforts to the maximum. Sweet. Okay, so add these all up for temperature. 0.3, buildings at 0.1, power and energy at 1.2, land use at 0.5. Okay, what does that come out to? Comes out to about 2.1. So with maximum effort, around 2 degrees of warming in the next 100 years. At the beginning of this lesson, so I had taken 1 degree, so is that possible with all our current technologies? Not even. And this is cool. This is a weather balloon. They send those up into space to test the temperature, or up into our atmosphere. All right, a new threshold might be better at 2 degrees. Two degrees. The world's governments have settled on 2 degrees as their target threshold. At the 2015 UN climate talks in Paris, a target warming threshold of 2 degrees Celsius above the baseline by 2100 was selected. Take a moment and set up the simulation below to result in this target being met. If it's not possible to meet, get as close as you can. So in this it says, will we meet our goal? Do you think this target is likely to be met with the current technologies? And so your answer to the right. Okay, so we want to set this up. We just showed that we need to have all these at the maximum. So go ahead and in order to set that up, have them toggle them all over to the maximum. Okay, so I'm just doing that same thing, clicking through, increasing all these efforts in order to get to just 2 degrees. Oh, I guess it's interesting to note, we're just looking at here to the 2100. So we could like take it down a notch on some of these efforts. Like let's say it's unreasonable. Like this would go above and beyond. Maybe if we go a little bit less. Oh, actually no, we're still above. Yeah, no matter what. So 2.1 projection, that's what we just saw. So is it reasonable? Go ahead and type your response there. Here it says, luckily we're an inventive species. Where might we do more? Of all the current technologies you've studied, to have one thing in common, there are always ways to reduce carbon dioxide emissions from human activity. Think back to what you've done so far. What are the factors that affect the temperature of the Earth? Alfredo, oh my gosh. Albedo, we have distance to the sun, we have our atmosphere, and solar luminosity. Those are the 4 factors we looked at in our blue planet and finding the cause. Which of these factors do you think are areas that could be changed deliberately by the human endeavor? We can change the composition of Earth's atmosphere, right? We're putting out different molecules into the atmosphere. We maybe could even change Earth's albedo. We looked at that with the coyote example, right? So coyote going up and busting the crust, allowing the sand to go up to the mountains, increasing or decreasing the albedo, increasing the absorption, increasing the temperature. So could we do that, but in the opposite way, right? It's hard to affect how much energy reaches the Earth from the sun, and we can't really change the distance from the sun. Oh, I guess maybe we could. We could change the energy reaching the Earth from the sun. And that is a lot based on these 2 first factors. So if we reduce the energy input, we need to just turn down the sun, right? One category of potential strategies that are being researched to reduce the warming trend is called solar radiation management. There are dozens of ideas for how we might carry out solar radiation management. Essentially, they all have the same goal, to reduce the amount of energy from the sun that is available to be retained on Earth. Some strategies focus on increasing Earth's albedo, how much light is reflected back into space. Others focus on reducing how much light makes it to Earth in the first place. Of the next few screens, you'll explore 2 potential strategies. These have promise, but there are many others being developed today, and even more that we can't begin to imagine, that we'll invent as time goes on. That you might even invent as a teenager going into the field. In 5 or 10 years, you might be on the forefront of developing these technologies. So let's reflect on the reflecting. Think back to what you learned in Finding the Cause about albedo, the fraction of light reflected by a planet or other body in space. In 1991, an event occurred which changed the Earth's albedo temporarily. What was that event? And you might remember that was a massive volcanic eruption in the Philippines. Mount Pinatubo erupted, scattering millions of kilograms of material into the atmosphere, increasing Earth's albedo for over a year. Mount Pinatubo event increased the albedo of Earth by releasing fine particles which remain suspended in the air. These fine particles are called aerosols. Aerosols scatter light, reflecting some of it and preventing it from reaching Earth. If human-made aerosols were introduced into the atmosphere, how could they reach your warming target? Aerosols would reduce the amount of carbon dioxide in the atmosphere. Well, that's not necessarily what they're saying here. Aerosols absorb some solar energy so that carbon dioxide can't absorb that energy. Aerosols bind to carbon dioxide. Aerosols don't affect, or aerosols reduce the amount of solar energy reaching the Earth, thereby reducing its temperature. That's right. So it's the sun's rays would come in and bounce back off, thereby not coming into Earth. We call that scattering light. Human efforts replicate this effort by adding sulfate particles to the atmosphere, which was the main component of the Mount Pinatubo eruption. Current research is studying the potential of many different aerosols in increasing albedo. This list includes sulfates and more exotic compounds like diamond dust and titanium dioxide. The latter is a major component of white paint. Take a moment to think about the possibility of adding aerosols to Earth's atmosphere deliberately, on intention. Do you think this would be a good idea? Why or why not? So I'll let you go ahead and think about that and come up with your own response there. Solar luminosity, dimming the lights a bit. Imagine for a moment that we could reduce the apparent luminosity or brightness of the sun. What would be the impact on Earth's climate of reducing the brightness of the sun? Less energy would arrive at Earth and the overall temperature would drop. Carbon dioxide would be removed. Carbon dioxide would increase. More energy would arrive at Earth and the overall temperature would rise. There would be no effect from scattering, reducing the amount of sunlight before it reaches Earth. So I would say if less energy arrives at Earth, the overall temperature will drop. So scattering light before it can reach Earth reduces the amount of energy that comes in, therefore reducing the global average temperatures. Thinking outside the box, in 2006, NASA approved funding to research a novel concept, using space-based lenses to scatter the sun's light before it reaches Earth. This technique reduces the apparent luminosity, brightness of the sun as viewed from Earth. That is pretty crazy, but ingenious, out-of-the-box thinking. Research into reducing solar brightness includes 2 novel ideas. The first method proposes using massive groups of lenses to scatter a small portion of the sun's light before it reaches Earth. The second strategy involves creating a giant screen or sunshade to block some of the light. Just a small change in brightness, 1% or 2%, would have a powerful effect. Take a moment to think about the possibility of reducing the brightness of the sun deliberately. Do you think it would be a good idea? Why or why not? Curious to see what you say there. Bring these ideas to the live lesson on Friday, and we'll continue to discuss them further. If we're adding carbon dioxide, can we subtract it too? Since we're adding carbon dioxide to the atmosphere, could we remove it as well? Scientists and engineers are busy researching different technologies to do exactly that. There are nearly as many potential ways to remove and store carbon as there are sources of it from human activity. Some are very technical in design. One example involves building massive factories to gather, separate and liquefy carbon dioxide to store it deep underground. Others are biological in nature. One such method is focused on developing highly efficient plants and algae to absorb carbon dioxide, then storing their remains underground or using them in other applications. On the next few screens, you'll explore two potential strategies. These may have promise, but there may be others developed today that we can't even begin to imagine. So, just a quick mention, you could track on over to this path and learn about this one particular method of hacking photosynthesis by charging up the Rubisco molecule. So a lot of you guys have summarized this point, which is awesome. Would also be better for agricultural needs. So let's see what strategies they have thought about. Removal and storage. Can we build a carbon dioxide vacuum? If carbon dioxide is behind the warming trend, why not just remove carbon dioxide from the atmosphere? What effect might this idea have on Earth's climate? So searching through here, more energy would make it to Earth's surface. No. Less energy would make it to Earth's surface and temperatures would drop. Carbon dioxide concentrations and temperatures would drop slowly. Less energy would make it to Earth's surface and temperatures would drop slowly. Yeah, probably is a slower effect, and there will be no effect from removing. Oh, hold on. Okay, yeah, that's a trick question a little bit. So the energy is making it in, right? But the greenhouse effect means that the energy is not leaving. It's being trapped. So the best answer here is carbon dioxide concentrations and temperatures would drop slowly. And here it says storing carbon dioxide would drop temperatures slowly as there's a lot of it and it would still be emitting at the same time. Ideas like compressing carbon dioxide to a liquid and storing it in large geological formations, i.e. rocks, or reacting it with metals to form carbonates like limestone are two of the many ways being researched to remove carbon dioxide from the atmosphere. Current research into carbon dioxide removal and storage includes areas like storing liquefied carbon dioxide in deep geological formations or reacting carbon dioxide with metal formations in the earth to form carbonate rocks. Take a minute to think about these concepts. Do you think this is a good idea or not? Go ahead and record your observation there. I'm going to pause. Okay, and this last one, biomass. Carbon dioxide, the real plant food. Several proposals to remove carbon dioxide from the atmosphere call for increasing the photosynthetic biomass. This is the amount of organisms that can make their energy from carbon dioxide and light on Earth. Think back to your experience with photosynthesis. What is the benefit to humans that might come from biomass absorption of carbon dioxide that wouldn't come from factories liquefying and storing it? Yeah, so maybe more oxygen's produced. Yeah, and we could use some of that biomass for fuel or be eaten. Current research into biomass, carbon dioxide removal and storage includes ideas like planting and growing fast-growing plants or using green algae to absorb the carbon dioxide and burying the remains to store the carbon underground. Take a minute to think about the concept of storing carbon dioxide using biomass. Do you think this is a good idea? Why or why not? Okay, go ahead and enter your, let's see here, we're coming up on it. All right, so then we get to this conclusion that we might hack the planet. If technologies can cause global change, can technology fix the problem as well? When we come to realize that we are global scale engineers, changing the face of our planet, new options open up to us. We can't know what new technologies the future will hold. Imagine thinking of today's smartphones just 20 years ago. However, several ideas that are currently being researched hold some promise. It's important to remember that the technologies we've been exploring are just a few of many, and we can't even predict what new ones will be developed in the future. The technologies we've been exploring have now been added to your model. Take some time to experiment and see where can we get with these new technologies. When you are done, set the levels to what you think is likely in today's political and social arena. Okay, so here this part is really nice. We got CO2 emissions. You can also just look at temperature. CO2 emission. Let's see if this, So here's some climate interventions. Let's look at carbon removal. How did that change? And if you want to go, we have to like track back to using the largest efforts. Or no, we can't change that, huh? So we can only look at really what these two would do. All right, but based on no effort, and then if we mitigated it, so it's shading these and moving it down to subtracting out 2.1 from carbon dioxide removal. And then temperature change from solar radiation management, like putting aerosols up in the air, goes down 0.5. So of these two, which one is more effective? And you might add that to your observation. Talk about these interventions. And then say your things. I got a dog in my hand, so it's hard to type. All right, next screen. Giving 110%. When we consider just two of the possible future technologies, where do we end up? Your model has been updated with your initial settings from both current and future technologies. Where does your initial model get our planet in 100 years with these new technologies added? To read the graph with climate intervention technologies, read the temperature value of the lowest black line. Here's the lowest black line. And let's look at temperature. We went down to 1.9. And is that within the limit? Okay, I was looking at land use. Careful there. So as I set these toggles, and it's cool to read these down here, what does it take? It takes accepting or managing possible unintended side effects. That's a big question, right? We're spraying things up into the atmosphere that might have some massive effects. You might be wary about doing that. And it's a massive project that requires financial commitments from all the world's governments. So total solar radiation management goes down -1 from where it was up here if we add these all up. 1.1. So go ahead and do your math there. You're going to subtract out your solar radiation management from the other levels that you have set. So what will it take to reach your goal? You will build a scenario to meet or stay beneath your warming target. The technologies and effort you use to meet your target will form the basis of your global plan to change the climate. Below, finalize your target warming. Remember, targets above 3 degrees have been ruled out by the world's governments due to their impact. Okay, so that's not a good baseline. So if you want to stay conservative at 2, if you want to go aggressive at 1, right now I think the current push is 1.5 based on the International Panel on Climate Change. Okay, once you have the scenario set up to meet your goal, in the way you're satisfied, you may continue. Once you continue, your target and plan will be finalized in your Blue Planet report and cannot be changed. Okay, so go ahead and toggle through each one of these. Which ones do you want to select? What do you need in order to reach that goal? And you can pause this recording. I'm just moving through so you get the directions. Meeting a goal, but at what cost? Think about your plan for a moment. What are some human consequences of your plan? Will cities, states, and countries be flooded? What about agriculture? What about the cost of technologies? Enter your answer to the right. Feel free to do a little bit of your own research and cite your own outside sources. We've included the consequence data from earlier for reference point. Okay, so this is, wait, where is it at? I guess you should be able to click these and say what's going to happen to each of the different areas, land area, and all of that. And then they want you to think about your plan from an ecological or environmental standpoint. What are the consequences of your plan? And I would go through and actually cite, you have to be over 100 characters, so cite each of those different areas: transportation, buildings, power and energy, and land use. Feel free to be creative. So in conclusion, where do we go from here? It's been a long journey from finding out what makes our planet blue to how it is changing and has changed, to the cause and effects of those changes, and our newfound ability as a species to shape our entire planet. These are great challenges ahead of us, but we have great resolve, intellect, and ability. With enough dedication and innovation, we can rise to these challenges, serious as they are. Once we do, the future of humanity is bright both on Earth and beyond. There's one last thing to do before you move on. Open up and finalize your Blue Planet plan. So you're going to go here, go to your Blue Planet, and go to My Design. And then you're going to work through, like for each one of these, you can add your observation. So you definitely would have wanted to add a lot of those observations that we just made. As you go through the lesson, you can actually add the observation. Like for this, you could add this multiple times, and that would help you build different scenarios. So if you're a really big fan of hydrogen fuel cell cars, that's like a scenario you've considered here. If you're a big fan of planting trees, maybe right here. If you're a big fan of using nuclear energy, there you go. And then your global plan you would add in here. And then your primary focus. What are you going to look at? Why is your plan good? What society must do for your plan to be implemented? The economic costs of your plan and the ecological costs of your plan. And that will be finalized for your next unit. Congrats! That's a little bit more work than we finished out here. So make sure to do that. And then Friday, we're going to talk about this book called Project Drawdown, which goes to even more solutions. For example, we're going to talk about the number 6 solution being educating women and girls. Can you think of why that might have an impact on the climate crisis? I'm also going to zoom in on other sort of creative plans. For example, number 4, eating a plant-rich diet. So we'll look at the benefits and consequences of maybe going vegan. We've talked about that before. And another one I want to zoom in on is reducing plant waste from foods. So think about, like, when's the last time you went to a restaurant and you were given way too much food? Well, maybe you haven't been to a restaurant in a while because of COVID, but. So yeah, anyways, I'll post some of these as options. This is a really cool book. We'll look at some of those and then talk about ways that you can actually get connected. So good luck finishing out your Blue Planet report. Let me know if you have any questions. Okay, bye-bye.